Good morning, everybody. Today we're going to move forward with our rational functions. Today we're going to finally start graphing them. So we're going to have two parts of my graphs because we have two different kinds of rational functions that we're going to experience. All right, let's talk about some vocabulary. We talked about the domain. It's going to be what my x's can and can't be. We've been doing this with finding our excluded values along the way. Zeros are my x-intercepts, so where my graph will be crossing the x-axis. New thing is called an asymptote. This is a line that our graph approaches but will never touch. It's like an electrical fence that we will get very, very close to, but we will never actually cross over it. And a discontinuity is the fact that our graph is not continuous. Okay, we're going to have two pieces of the graph. We'll graph one part. We'll have to lift our pencil to graph the other half of it. Okay, so this is my first type of graph. We have 2x over x minus 4. Okay, so if I gave you this and I said at what value is x undefined, you would take your denominator, you would say x minus 4 equals 0, add that 4 over. It is for the value of 4, because 4 minus 4 is 0, and we cannot divide by 0. Next, let's make a t-chart surrounding that x value. So let's go a little bit below and a little bit above that x value. So what we're going to do is we're going to plug these values in, and we're going to plug them into my equation and see what I get out of it. So 2 times 0 divided by 0 minus 4. 2 times 1 divided by 1 minus 4. We're going to do that over and over again, and we are going to be able to complete my table. So notice when we plugged in 4, we got undefined, right? Because 2 times 4 is 8, but 4 minus 4 is 0. So that's why it's undefined. That's the whole point. Okay? So each of these values were found by plugging them in to this x and this x. Now we're going to plot these points. Oops, sorry. I went ahead of myself. So my vertical line right here, this x equals 4. This is called a vertical asymptote. So this is like my line, this is my electric fence on my graph where my lines won't touch. You're going to see that. So notice when I plot my points, and they kind of curve when they're reaching the point of x equals 4. Okay, so they're bending when they reach x equals 4. Okay. Something else we're also going to have, we're going to explore by plugging in extreme values. So if I replace x with a 10, a 100, a 1000, negative 10, negative 100, negative 1000, okay, these are the values we get here. I'll notice my x's, they're getting really close to the value of 2, okay, but they never actually equal 2. We have 2.008. We have 1.992. We're getting close to 2, which means y equals to 2 is a horizontal asymptote of our function. So they're curving when they reach x equals, right here, this is the x equals 4, that's our vertical asymptote. And then here is y equals 2. So they're also curving at y equals 2 and at x equals 4. That's what makes them curve on both sides. Okay, so we have vertical and we have horizontal asymptotes. Okay, a vertical asymptote, we just figured this out, is where the denominator is equal to 0. Horizontal asymptotes, okay? There are 3 different kinds of horizontal asymptotes. The one we just did is an example of what we have right here. It's all about where your power is. So here I have 6x squared minus 3x plus 4 and 2x squared minus 8. Notice my powers, they both have 6x squared, 2x squared, they both have the x squared. So when they're the same, we take those leading terms and we simplify it. Here we get 3, so y equals 3, that's the horizontal asymptote. Okay, that's what happened. I'm going to go back. That's what happened with this problem. Look, it's 2x and x, right? So our horizontal asymptote with this one, my leading terms, 2x over x, that simplifies to just 2. So my horizontal asymptote was y equals 2. Okay, so that's why it happens. All right. Another example here is if my biggest power is going to be on the bottom. So notice my bottom has an x squared. It's the biggest one. What happens is it's going to reach up. It's going... I'm not going to do that with y'all. If my bottom is at the highest power, we have a y equals 0 for a horizontal asymptote. The last example is if my highest power is on the top. Here I have 4x squared on the top. When this happens, I don't have one. It kind of crushes it out. The top's so heavy, it crushes it. I do not have a horizontal asymptote. Okay? Let's do another one knowing that stuff. Here we go. We have the function x over x plus 2. Where will the discontinuity occur? Or where are we undefined? Well, what would make my denominator 0? It would happen if x was negative 2. Let's create my t-table, going a little bit above and below that negative 2. Just like last time, plug them in. Negative 5 over negative 5 plus 2, and then negative 4 over negative 4 plus 2, and so on to complete our table. Okay. Plot those points, see my curves. We also right here, this is that x equals negative 2. That's where we're going to approach it, but we're not ever going to actually touch it. Okay. The horizontal asymptote for this one, we could plug in extremes again, right? The extremes help us. The vertical asymptote is x equals negative 2. Plugging in the extremes help me for my horizontal asymptote. I can also do the trick I did before and look at where my highest power is. I notice here they both have an x. So leading term over leading term, that simplifies. X divided by x is just 1. So I bet you my horizontal asymptote will be y equals 1. Plug in extreme values, and yep, they are getting close to 1, but they are not touching it. So that is my horizontal asymptote, which I can draw across. You can see the curves bending right there also. Okay. One more. Consider the function negative 4 over x. What values of x can we not have? Well, the only thing I can't have x equals 0, right? Because then that would be 0. So 0 is not going to work. What are the equations? I don't know why I wrote that. What are the equations of the vertical and horizontal asymptotes? Okay, well, vertical asymptote comes from what I just did, right? X. So x equals 0 is my vertical asymptote. Horizontal asymptote, where's my highest power? My highest power is on the bottom. Remember, my highest power is on the bottom. That's also going to be a y equals 0. So vertical asymptote comes from here. Horizontal asymptote is because that my biggest power was on the bottom. So we do not have a horizontal asymptote. Or we do, I'm sorry, it's y equals 0. All right, so now let's go ahead and sketch those asymptotes, and we're going to complete the t-chart. So we're going to go above and below that 0, just like last time. Negative 4 divided by negative 4, negative 4 divided by negative 3. Keep plugging values in to complete our table. My asymptotes are the x and y axis, and we'll see my points are curving on either side of them. Okay, so this is the first kind of graphs that you're going to explore. The second kind of graphs, let me pull that one up. Yes, here we go. All right, the second kind of graphs. So notice all of those, we never had to factor and cancel out common terms, which is what we're used to doing with rationals, okay? The next ones is going to see what happens when I cancel out common terms. That's something that happens for me. This gives me a point of discontinuity, okay? A point. So it's going to be a break or a hole in the actual graph. So if I go to do my curves like this, and on my other side, and there's a hole, you actually stop, draw a hole, and then keep going. Something like that, okay? So these that we're about to see are going to have a hole in my graph, okay? So what we always do first is we're going to factor our denominator. For this one, when we factor, we are going to get, so multiplies to give you negative 6, adds to give you negative 1. That's going to be positive 2, negative 3. So each of these gives me an undefined value, so -2, -3. If I reduce my fraction, notice all I have left is just the 3, okay? So that gives me my vertical asymptote. So my vertical asymptote is going to be x equals 3. Vertical asymptote x equals 3. Okay, because that's what was left after I simplified it. Okay. If I do my t-chart, and I see what happens, plug them in. I'm plugging them into 1 over x minus 3. Use your simplified value. Okay. Whoops. Okay, so we have my t-chart. I see they go above and below. Let's see here. 2, -1. Like that. What does this do? -0.5, -3. And get really close, something like that. All right, so the vertical line, we have it as x equals 3, okay? But the other point that we were able to remove, so what did we remove from our equation? We removed x plus 2, correct? Yes, x plus 2 got removed. So that's going to give me a removable point. So we simplify the piece that we got to remove. So we're going to take x plus 2. X cannot equal -2. So we're going to have a hole at -2. Okay, and don't worry about this part. We're not going to do that. So we have a hole at x equals -2. Okay, so there's going to be a hole in my graph. I'm going to show it to you here in a minute. Okay, we still have horizontal asymptotes. I could actually go back to the beginning if I want to. Look right here. Where's my highest power? It's on the bottom. So that means that my horizontal asymptote is going to be y equals 0. Again, ignore this part. Okay, let's actually plot these points. So we plot the points because we have a hole at x equals -2. When I got to that point in my graph, see how there's an actual hole right here? And then we continued moving on. Okay, so you're going to actually draw a hole in the graph. Okay, let's do one more. All right, so consider the function. We have x squared minus 4x plus 3 over x squared minus x minus 6. So what I'm going to do is I'm going to go ahead and factor. So multiplies to give me 3, adds to give me -4. That's going to be -3 and -1. Multiplies to give me -6, adds to give me a -1. Is going to be x minus 3 and x plus 2. So we're going to have some kind of discontinuance, whether it's an asymptote or a hole. It's going to happen at 3 and -2. I don't know which one yet. Okay. After we simplify my fraction, though, I notice my x minus 3's cancel out. We're left with just x minus 1 over x plus 2. So what does that mean? That means what's left, my x plus 2, my vertical asymptote is going to be x equals -2. And my other piece is going to be my hole. We're going to have a hole at x equals 3. So both of these gave me some kind of discontinuity. What got canceled out is my hole. I cancel it out of the equation. We're going to cancel out of my graph. What's left is my vertical asymptote. I'm also going to go ahead and do my horizontal asymptote. If I look, they both have the same power, so I'm going to simplify. X squared over x squared is going to simplify to be y equals 1. So I'm going to go ahead and draw my asymptotes. Here's y is 1. Here's where x is -2. I can't graph my hole yet. I will make sure I mark that, though, when I do my curves. All right, so now let's make us a t-table. Let's go a little bit below and a little bit above that -2. So let's do what? -3, -4, -5, and then my other direction like that. Plug them into your simplified version. Okay, so we're going to have -5 minus 1 divided by, which is what, -6, divided by -5 plus 2, which is -3. So that's going to be a 2. -4 minus 1 is -5, divided by -4 plus 2 is -2. That's about a 2.5. -3 minus 1 is -4, divided by -3 plus 2. So that's going to be a -1. So this is going to be a +4. -2 gives me an error, doesn't it? I don't need to actually put. I know that's going to be an error, so I don't need that. Let's jump to 1, 0, 1. All right, -1 minus 1 is -2, divided by -1 plus 2, which is 1. So that's going to go -1. 0 minus 1 over 0 plus 2 gives me -1/2, so -0.5. 1 minus 1 is 0 over 0 plus 2, so it's going to be 0. So I'm going to plot these points. 1, 2, 3, 4, 5, up 2, which is this one right here. Here we go. -4 and 2.5. I put these in the wrong ones. There we go. -3 and 4. -1, -1. We're down here. 0.5, so we're getting really close. So I have a curve going this direction, and I have a curve over here. I gotta be careful because when I reach x equals 3, 1, 2, 3, I have to stop and draw a hole and then keep going. Okay, so this hole at x equals +3, when I drew my curve and I got to 1, 2, 3, I stopped and I drew that hole in my actual graph. Okay, remember these are asymptotes. That is my horizontal asymptote. And then this guy going up and down right here, that was my vertical asymptote. Okay, not too bad. I believe we have one more. Let me get through all this. We already wrote this down. Again, don't worry about this. We have all of this. There's my graph. I like the one I drew better. That's why I drew it. All right, let's do one more. Okay, so here we go. We have x squared minus 3x over x squared plus x minus 12. So the first thing I'm going to do is factor. So my top is going to be, I can take an x out of both of those, so x over x minus 3. Our denominator multiplies to give me -12, adds to give me a 1. So that's going to be +4 and -3. So I know I'm going to have discontinuities. It's going to happen at 4 and it's going to happen at 3. Which one's the line and which one's the hole? Well, since my x minus 3 is going to cancel, leaving me with x over x plus 4, that means that my vertical asymptote is going to be x equals -4. That's what's left in my denominator. I'm going to go ahead and draw that. 1, 2, 3, 4. That's this guy. Now, what got to be canceled out, that x minus 3, that's going to be my hole. So now we have a hole. We cancel out x minus 3, so that's x equals +3. I can't do anything with it right now. When I go to draw my curves, where's x? This is x equals 3. Anywhere on this line, when I do a curve, I got to stop and do a 0. Okay. I'm also going to go ahead and do my horizontal asymptote. So I see my powers, again, they're the same. X squared over x squared gives me 1. So my horizontal asymptote is going to be y equals 1, which is right here. All right, so let's plug in some points. We're going to go a little bit above, a little bit below the -4. So let's go -5. I didn't change my color. Purple. There we go. -5, -6, -7, and then on the other side of -4, let's do -3, -2, and -1. All right, we're going to plug these in. to our our simplified version. So negative 7 divided by negative 7 plus 4, which is negative 3, gives me about 2.3. Negative 6 divided by negative 6 plus 4, which is negative 2, gives me a 3. Negative 5 divided by, what's that going to be? Negative 1. This gives me a 5. We see this is where the jump's going to happen. Okay, so negative 5, 1, 2, 3, 4, 5. Negative 6, 3. Negative 7, 2.3, about right here. Oh, I can't do it. Drew at the wrong spot. There we go. So there's this curve, which is fine. I can draw it because my hole's not over there. My hole's over here. So now my other side. We got negative 3 divided by negative 3 plus 4, which is 1. So negative 3 divided by 1 is negative 3. 1, 2, 3. 1, 2, 3. All right. Negative 2 divided by negative 2 plus 4, which is 2. So that gives me a negative 1. So negative 2, negative 1. Plug in negative 1, we get negative 1 divided by negative 1 plus 4, which is 3. So it's going to be a negative 0.3. About right here. So when I go to draw these curves, I connect these. I keep going. There's x equals 3. I draw a hole, and I keep going. All right, so this right here was the hole in my graph. And I did that when I reached x equals 3 right here. Right? I think that's it. Let's keep it. Yes, that was the last one. Okay. Last one of our notes. So you have homework to do. The front page is the ones we did in the PowerPoint before this. The back of it is going to be the ones like we just did where you have to factor and stuff. So the front page, you're not going to have any holes. You will have vertical and horizontal asymptotes you need to look for. The back of the page, it asks you for different pieces of different things. The back is where you're going to have your holes and your vertical and horizontal asymptotes. All right, so work on that. I also have already posted your quiz review. Start working on that also. We're going to quiz on Friday.